Good morning. This is the home version of our videos. I did not put up an agenda because I'm not at school, but here is a one-liner for you. If Iron Man and Silver Surfer teamed up, they'd be alloys. Get it, like allies, but alloys, because they're both metals. Okay, I'm going to split this video up into two videos, this lesson into two videos. The first is going over the homework you see in front of you, and then we will continue with the next set of notes on a separate video. This is close to the last of the material. We're still looking at a test that I'm going to have due Thursday at 3:15, and then we will start review on Friday. So let's also plan on Wednesday afternoon having a Google Meet so you can ask any questions that you would like. Okay, so I wanted you to do this sheet here, and let's go through it piece by piece. Okay, this is all based on Table J. And Table J is here. I've got my CRT here. And just as a reminder, Table J shows you the most active metals at the top and then the least active on the bottom. So what that means in terms of oxidation and reduction is that these at the top are more likely to be oxidized, and these on the bottom are more likely to get reduced. Now, another thing that we should keep in mind is if we have two metals that are in association with each other, in other words, two metal strips in a solution, we also have to think of what's going to happen with the electrons, because there's going to be a transfer of electrons. That's what redox is. So, in that case, electrons are always going to be drawn to the atom that has the greater electronegativity. So for example, if we looked at zinc here, and we had a strip of zinc in with a strip of iron, since zinc is more active, that means it has, it's going to be more easily oxidized. That means iron is going to get reduced. Now remind yourself of what reduction and oxidation is. Oxidation is the loss of electrons, and reduction is the gain of electrons. So which do you think of these two would have a stronger electronegativity, a higher electronegativity? Well, the gaining of electrons means that those electrons must have been pulled from something. And in order for something to pull electrons off of something else, it has a higher electronegativity. So iron has a higher electronegativity than zinc. Therefore, it pulls the electrons from zinc in order to reduce or gain electrons for the iron. Okay? So that's essentially the background with the Table J. Remember that this is the order of the nonmetals. There are some questions here as well. And someone asked, well, why are they F2, Cl2, Br2? Remember Hofbrinkel. These things are so reactive, and all of them happen to be in the group 17, the halogens, that once you were not going to find them as singular atoms. They will always be diatomic or in some sort of molecule. Okay, so let's take a look. The most reactive metal according to Table J, it's at the top, that's lithium. The most easily oxidized metal according to Table J is the same thing. Easily oxidized and most reactive, we're going to think of them as synonyms. The most reactive nonmetal according to Table J is fluorine, and I'm going to go ahead and write it as F2, okay? As I just said, it's not found by itself. The most easily reduced nonmetal according to table J, would be I2. So the thing that is most easily reduced is the least reactive. Okay, so that's at the bottom of that list. The metal that is the best oxidizing agent, that's a good review for you. An oxidizing agent is the thing that gets reduced. And the thing that is going to be the best oxidizing agent is the thing that is going to reduce the most, and that would be down at the very bottom, and that is gold, AU. The nonmetal that is the best oxidizing agent according to table J is I2. Okay, so nonmetal that is best oxidizing agent, that means same thing. It's the thing that's going to get reduced, which means it's the least reactive according to what the table shows me. The metal that is the best reducing agent according to table J, so now we're talking about the metal, and it's the best reducing agent. If it's the best reducing agent, that means it's the most easily oxidized, and we have lithium again. So these are repeating a little bit, which is good because you should be able to understand and recognize the different ways that they might ask a question. The nonmetal that is the best reducing agent according to table J is going to be at the top. So that would be, I almost said iron, fluorine gas. Okay, this next section here is only a statement. I don't really like the way they put it, but it's just a statement, just to have you realize what's going on. Okay, now we're going to go through each one of these and see which ones will occur spontaneously. Now, what does that mean? That means if I have a beaker of nickel and copper nitrate, so I've got a beaker and I've got a solution here of copper nitrate, and I have a strip of zinc. Will anything happen? Well, let's look at table J. We're looking at nickel and copper. So will nickel displace copper, leaving copper by itself and forming nickel nitrate? Well, here's our table. Let's find nickel. Here's nickel. It's allergy season, in case you were wondering what that honking was in the background. Nickel, and here is copper. So nickel, according to this, is more active than copper, which means it's going to lose electrons and kick out copper. So nickel kicks out copper, copper gets reduced into copper solid, and it's going to form at the bottom. It's actually going to form on the strip itself. And then that copper nitrate is going to fade away. It's going to go from blue to a pale color. So this is going to happen. So how am I doing this? I'm finding what the metal is, the two metals. I'm identifying the two metals and seeing which one is more active. If the one that starts out as a solid is more active than the one that is in solution, then it will occur spontaneously. Let's look at B. Lead and zinc. Let's look to see where they are on the activity series. Lead is down here. Zinc is up here. So which one is more reactive? Zinc. So zinc will displace lead, but lead will not displace zinc. Lead is not going to kick out zinc, so this will not happen. Okay? Now, if we hook this up to a battery, it would happen, because then we would have enough electricity to make it happen. Letter C, magnesium and iron. Is magnesium above iron? Magnesium is above iron. so that is a check. Tin and silver. Well, you might remember that silver is way down here at the bottom. So tin is not that much higher, but it's still higher enough to kick silver out of solution and have it form a solid. Now this is written a little bit differently in that there's no S here, but you have to assume that this is a solid because there's no ion, negative or positive here. And then when we get over to this side, you can see that it is an ion. So essentially what they've done here in E, F, and G is the same thing here, except they haven't written whatever the other polyatomic ion is in the solution. So they've shortened it, abbreviated it a little bit. It's the same idea though. Will sodium displace zinc to allow zinc to become solid? Sodium, zinc. Sodium is above zinc, therefore this will happen. Tin and aluminum. Here's tin way at the bottom. Here's aluminum. Now aluminum will kick out tin. So in this direction, from right to left, that would happen, but tin is not going to kick out aluminum. That's a no. Copper is almost at the bottom. It's the third one from the bottom. Chromium is about 2/3 of the way down. So that will also not happen. Okay, so hopefully you followed that logic on that one. Next section. Nonmetals higher on table J can oxidize, and this all means the same thing, below them. So this is another statement. Which of the following reactions will occur spontaneously? So this is the same idea. The difference is we're looking at the nonmetals here. So if it's above it, it is more reactive and it will kick out. So fluorine will kick out chlorine, bromine, and iodine. Chlorine will kick out bromine and iodine, but will not kick out fluorine. So what do we have the first one? Bromine and iodine. Bromine is above iodine. That means it's going to kick it out, and that's a positive. Chlorine and bromine. Well, chlorine is above bromine, so chlorine gas will kick out hydrobromic acid, so that will happen. Iodine, and here's the part of the other nonmetal half, hydrofluoric acid. Iodine is below F2, or excuse me, F, fluorine. So it's not going to be able to kick it out. It's less reactive. And we've got chlorine and fluorine. Well, you know fluorine is the most reactive, so that one's out. And since fluorine is the most reactive, it will kick out bromine. So we end up having this be a positive. Okay? So, metals higher than H2 can react spontaneously with acids to dissolve and produce hydrogen gas. Now, we did this earlier in the year when we were talking about the properties of acids, I believe. Which of the following reactions will occur spontaneously? So it's the same idea. Let's remind you of where hydrogen is on this thing. Hydrogen is here. So anything above hydrogen here will displace, the acid will react with it, and then it will cause hydrogen gas to become liberated, and then you get that popping sound with if you've got a flame there. So which of the following reactions will occur spontaneously? We've got chromium and HCl. So chromium, is it above hydrogen here? So it is. We've got chromium, which is here. Hydrogen gas is here. So since it's above it, it will react and then kick out the hydrogen gas. So remember, this is the end product here. So this is a check. This will happen. Copper and chlorine. Well, reminder, copper is one of the last three. Copper, silver, and gold. Copper is below hydrogen, so this will not happen. So if I put copper, a strip of copper in hydrochloric acid, it will not release gas. Magnesium is also above hydrogen, so that will happen. And the last one's just a multiple choice. Which of the following elements can react with an acid to produce hydrogen gas? So really what they're asking is, which one of those is above hydrogen on the table J reactivity series? Well, these are the three bottom, right? So gold is in the very bottom, then silver, then copper. Gold, silver, copper, and then hydrogen is above that. So these three are out. So you're only left with calcium, which is the answer. Okay, next video will be the next type of electrochemical cell called a voltaic or galvanic cell. It's really just a battery. See you then.